before we start, just a little heads up. Tuesday's the stats test, and then right after that, we get going with the Regents review. All right, all period long. I need from you, and this is why I'm telling you now, by Wednesday, to have a binder solely dedicated to Regents. All right. If you need one, this is my vast collection I've collected over the years. If you need to borrow one just for the Regents exam, I'm fine with that. Okay, but I need a binder solely dedicated to everything I'm going to hand out to you because it's going to be a lot. All right, as far as the Regents exam goes. Good there? Second thing, figure out what you're going to do about a calculator. All right, I know I have all those on the back that people borrow from time to time. That's all I have. And people use them in this class and people use them in my 5th period class. I don't have enough for everybody to use. All right. And by the way, if you want to borrow one, my rule is you come to a review session and you can borrow one. Okay. That's my rule. All right. You want to borrow a calculator from me, come to a review session. All right. So get a binder by Wednesday. All right. Because I'm going to be handing out a lot of stuff. And figure out what your calculator situation is soon. All right. 3 weeks from yesterday, remember. All good? Number 27. Here we go. 27 from the Regents exam. I'm trying to pick questions that I know are commonly asked from year to year. This one's on rate of change. Rate of change. Determine the rate of change. This is a formula that you're going to need to know. On Wednesday, I'm going to hand you guys a few sheets of formulas that are not on your formula sheet that you are responsible for. One of them is rate of change. Anybody remember that formula? Or just want to take a guess at it? Because I think you'd be right if you took a guess at it. Rate of change. Y over X. Yep, change in Y over change in X. Y on top, X on the bottom. Yep. Okay, where do I get these values? Usually on the Regents, they will give you the X values. All right, as you read through this problem right here, you will see that I need the rate of change from 4 to 8. There's your X values. 8 minus 4 on the bottom. There's your change in X. 8 minus 4. They will usually give those. Now, where do I get the Y values then? When this is 8, I need its Y value. When this is 4, I need its Y value. Where am I going to get that from this problem? Where am I going to get those values to subtract on top? The equation. I'm going to take 8 and plug it in, not for X, but in this case for T. All right? What's the Y value for 4? I'm going to plug it in for T. All right? This E here, that's not a variable. That is on your calculator. Anybody know where it is? Right above the division sign. It's an actual number. Okay, that's not a variable. That's an actual number. It's like pi. Okay, so don't plug in for that. So what I need you to do on your own right now, so you get practice using your calculator, plug in 8, plug in 4. Those are your Y values you're going to subtract. So go right ahead. Plug in 8, plug in 4. And when I say plug in, this is up to you. I would store them. All right, store in 8 and store in 4 for X. Or T if you want to use T. You like the one, what it is in the problem. So plug in 8, plug in 4, and see what your change in Y is going to be. Okay, your change in Y. So I need this value minus this value. This will be when you plug in 8 into the equation. You get a value out. This will be when you plug in 4 for T. You'll get a value out. Okay? I use the equations to get the Y values. Above your division sign. Everyone, we getting 195? Okay. Notice what I didn't do, though, to that number I got in my calculator. Don't round it. Don't round it, because it may throw off your final answer. The only thing you guys should be rounding is the final answer. Don't round mid-problem, because it could throw off your answer at the end. So I'm going to ask somebody to finish this for me. Rate of change to the nearest hundredth. So go ahead, find your rate of change to the nearest hundredth now. I did the change in Y, change in X, perfect. I just got to know how to round appropriately. Where am I here? 5, nearest hundredth. All good with you guys? Now, another comment here. I do want, obviously, for you guys to be successful and hit that 26-point mark or a lot more than that. If you round incorrectly, usually if you're taking a test in here with me, half a point. There's no half a points, though, in the Regents. It's a full point. Be careful, please, okay? Because imagine that, huh? You get 25 instead of 26 because you didn't round correctly. All good? We're going to be ready for this, huh? Oh, boy.
Heck yeah.
I got 33 of you I got to get through. 33 kids. All right, good? Don't cheat. Don't open up anything. Here we go for Tuesday. Margin of error formula. Margin, again, these are formulas you're not going to be provided on Tuesday. Whoa, 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 easy, easy, champs, easy. I want just from 10, just from 10. Margin of error. 10. You have to look it up, Bella. Go ahead. You'll remember it more. You'll remember it now. Thank you. Nice job. How about my confidence interval? How do I find that 95%? I'm 95% confident the mean is in between these two. 13. Thank you. How about 11?
So you want to know how you find it?
What's the formula? How do you find the CI interval, confidence interval?
Oh, wait, wasn't it Mo? Oh, I'm sorry. Hold on. My boy Mo. Oh, mean plus or minus the Mo.
What's Mo?
Margin of error.
Okay, good. That's why I asked for it first. We haven't done this next one for quite a bit. Talked about it right at the beginning of the unit. Interquartile range. How do I find the interquartile range? Oh boy, 5. Good. Whoa, whoa, whoa. Where do I find Q3 and Q1? Okay, you put stuff in a list, right? Put stuff in a list. Stat. Which one gives me? One var stats. Yep, one var stats. Normal distribution. Anybody know where I go? If I see normal distribution in the problem, where do I go on the calc? Second, vars. Which selection do I pick on second vars? Here you go, second vars. Normal CDF. Yep, choice 2. Good, good. All right, if it is normally distributed, what percent of scores are within 1? So from -1 to 1, what percent of scores? Anybody remember? 60? 8%. That's why we're reviewing. What about if it's within 2, from -2 to +2? That's 95% from -2 to 2. All right, with those formulas. Still got your regents out? Question 32. Question 32. A lot of stats on the regents. Got our simulation like usual.
Never ends.
It doesn't.
Can't get out.
It's only a 2-point question because what they're asking for is pretty easy if we know the formula.
Yes.
We have to. What do we have to find? Determine our.
Margin.
Okay, that's a formula.
The amount. All this is the amount.
Partial credit's tough here unless you round wrong, I think. It's either you know the formula or you don't, which was plus or minus 2 times standard deviation. All right. And they provide it for you. Yeah, what is the standard deviation? 13? Not here. Thank you. How about 6 standard deviation? Yeah. It's right there. It just, hey, here's 2 points if you know the formula. Keep the plus or minus, don't drop it. And please round to the nearest hundredth. Hundredth. 10? There it is. There's first part of this question. And what's that mean? Okay, remember, this, ready? Here you go. This mean is not for the entire population. How many people did we sample? 200. So that means only for the 200 samples. What this is saying is if I wanted to go to the whole population, the mean, from the 0.350. Okay, so here's what it means. Here's what it's telling me. The population mean, because right now, hey, just so we're clear, I want to take this slow. What's the 0.350? That's the mean for this 200 sample, not the entire population. So the population mean is 0.08 above or, because we have the minus, right? Or below, what's the sample mean? 0.350. Okay, that's what it's telling you. That's not the population mean, the 0.350. The population one is 0.08 above or below it. All good there. Put away that regents. Let's get reviewing for Tuesday's test. It's time to teach me. 37, page 37. One more of these. We did a ton of them yesterday. One more of these. I think I put 3 of them on the test. 3 of them. Okay, page 37. You can look about meander corn plants. You just got to at least love the word problems, even though you don't have no idea how to do it. You can at least just love to read them. Here's what she's saying. Synthetic light will make them grow slower than natural light. How about that? Give them synthetic light, they'll grow less than if they're in natural light. Let's see if that's true or not. So part A, can you guys calculate x2 minus x1 for me? All those values are given. Just asking you to subtract them. The difference in the means. When when you have that value. Let me know 1 when you have that value. Yep. And how did we get it? 24.1 minus 17.9, 6.2. So based on that calculation he just gave us, is Mia correct? Does this calculation only, support Mia's belief? Yes. Why? Yes. Here we go. Ready? On average. All right, I'm going to ask somebody, what's the 6.2 mean? On average. 3, can you relate it back to the problem? On average. What are the two numbers we subtracted, Elena, to get the 6.2? Which were 17.9 and 24.1, right? What's that represent? What's 24.1 centimeters is the what? The height, right? So that 6.2 corresponds to the height. So we could say, yes, on average, which group, by the way, was higher? So on average, natural light grew 6.2 centimeters higher. Or if you guys want to go the other direction, I could say what? Synthetic light grew lower, correct. Okay? So she is correct right now anyway, but that could just be by random chance. So we did the big simulation, you guys know. Okay, 6.2, locate it. Because I don't see any standard deviation or mean that we can do a confidence interval for, so. Everyone see where 6.2 would be? Somewhere in there, right? So because it's there, is there significant increase in plant growth due to the light? I still get nervous that you guys are going to mix this up.
Yes.
Good, good. The answer is yes, but I got to show it mathematically, right? 3 again. Elena, how many are at or above 6.2? Out of, you don't have to count them. 100 times, yep. 1 out of 100. That's 1%. What's our cutoff? 2.5 or below, right? 2.5 or below.
Wait, so
Go ahead.
I understand. Like I knew to say yes to your question.
Okay, so here's what happened. Okay, here's what happened. We had 15 and 15, right? 2 groups, one group of 15, another group of 15, right? I calculated their heights. I did the average. This is what it came out to be. Okay? Then here's what I did, Ben. All these 15, boom, I just randomly put them in another group of 15, regardless if they got natural light or synthetic, right? I did it again. Boom, boom, random 15, found the averages, did it again. And I plotted all these numbers here. Okay? These are all by random chance. All these dots I have up here are by taking the group of 15 and the other group of 15 and literally just closing my eyes and putting them in different groups, regardless if they got natural or synthetic. Good? Where did mine end up? Way away from the guys that were just by random chance. So it's probably unlikely that I got 6.2 centimeters higher by random chance, because look where it is on the plot. So if it's not by random chance, it's significant because it was probably because of the light I gave it. Okay? If it ended up somewhere in here with all the other random chance dots, yeah, probably because of random chance and not the light. Lauren.
Oh, okay. See the dots like that on directly above 6? What are they? Because it's hard to tell.
They're right above you.
Are they?
Okay, even if you didn't, 3 versus 1 won't affect the answer here. Okay? It's still like on the extreme outside.
Isn't it like 2 points below 2.5?
All right, I'm going to adjust. We're going to go with 5 from now on. Okay, 5. Let's go with 5% from now on. No, totally understand what you're saying. Let's go for 5% from now on. Okay, anything under 5%, That's unusual or significant. Okay, everybody good? 5% or below. Good point, Lauren. Good point. Ben, are you good now?
Yes.
And why it's not by random chance, or we're saying it's because of the light.
Yes.
Okay. So this is, yes, it is significant. Because only 1% of heights, not scores in this case, heights are above 6.2. And I'm going to be really flexible on your wording here. It doesn't have to match mine. I'm going to be real flexible. I just want to make sure you understand if it's outside versus inside. All good, guys. We feel comfortable there? I'm going to put about three of those on the test. It's the weekend, right?
No. Great way to end it all. Let's rock.
Elizabeth, page 30. Keep going backwards. It's the start of the review. Question 1, start of the review. 32, page 32. Worst part of this unit by far is the reading. It's very wordy, all these problems. Oh, Elizabeth. She waited 6 minutes for her fast food last time she visited.
She told the manager.
Well, she thought she was upset. She thought she waited longer than normal.
So what?
She had an unusual wait time.
So many reasons that could have happened. Wait outside the confidence interval.
So I want to know, waiting 6 minutes, unusual. Use a 90% confidence. All right. So here's our formula. We got to find, help me find that level of confidence. Mean plus or minus my margin of error, right? Help me find this interval, and then I'll see if 6 minutes is inside or outside it. All right, what's the mean here? 226 seconds on average. Plus or minus, we got to go off to the side here and find the margin of error. Which will be what? Plus or minus 2 times, which is 38. So your margin of error is plus or minus 60, 70, 76. So where are we? You should be waiting between what? Number 9 when you're ready. You should be waiting between. Yep, should be. Ooh, a little wrinkle here. Anybody see the wrinkle?
I see no wrinkles. All I see are numbers.
What? Divide by 60? Oh, you want to divide this by 60? No, that was the. She waited 6 minutes, right? The 150 and 302 are in seconds. Okay, you're dividing these two by 6. I'm taking the minutes and putting them into whatever. Yeah, whatever. Yep.
I don't think it is.
Okay, do your own thing. Go ahead.
I think Mr. Carlino's not tricking us today.
How many seconds?
360.
360 seconds, right?
Yikes. Outside of
So is her wait time a little unusual or not?
It's rightfully noted.
Yes, it is. Yes. Because it is outside our confidence interval.
Like 6 minutes is a long time. Dude, they make me pull from the front. Yeah. Like if you're in a rush, you need fast food. She went.
If you're in a rush, you can
It's
stop.
actually it could be 6 minutes.
If you're in a rush, you don't.
And I can't.
She took time out of her day.
I'm probably going to regret this, but drive through Annoys me.
You're not in a rush if you have to get.
On her way to.
Annoys me. Get out of the car and walk.
On her way.
What if you can't walk?
Okay.
To deliver.
Point taken, but
We can all walk here.
She was delivering her child.
If you are in a rush, you
You
aren't
wouldn't have
getting
a job
food.
if people were not lazy and didn't want to.
That's true. Pizza delivery, Uber Eats.
just getting lazier and lazier. Get out of the
That
car.
would suck.
Shouldn't you be happy
Get out of the car
You should be
I
happy
spent
other
like
people
10
and
minutes
walk.
sitting there, and I was like, this is abnormal.
Get out of the car and walk.
That's true. Also, do you want like a bunch of people in McDonald's at the same time as you? Sometimes it's just a little nerve wracking. Like, it's like
That's
a
true.
completely packed.
I don't remember the last time.
I can't help it if you're socially awkward. Just, yeah.
All right, back to
Yeah. Yeah. So basically, you're just going up. How can I help you, sir? You're just running.
Can I?
Yeah, I'm good. Yeah, I'm good. French fry. I'm going. French fry.
I'm so sorry.
What?
How's that different than if you pull up to the window and have to give money and
You're not ordering
just throw it? I should make fun. I'm sure there's some people that aren't a big fan of that, but all right. Good conversation. Yeah. Whew. All right. Heights of male students. Right away. Alarm should be going off.
Bell curve.
Yep. Where am I going? Probably. Where am I probably going here? Normal CDF. Yep. Let's read. Well, let's keep reading through the question though. What's the probability a male student taller than 74 inches? Taller than 74. So because remember, let's go there right now. You're going to have to put in a range, right? A lower and an upper. Taller than 74. What would my lower be? 74. Does it give me an endpoint? 74. Just says 74 and above. So what's the number I put in? Ooh, not -1 though. 1. Double E, which is above your comma button, 99, scientific notation, 10 to the 99. Ooh, all right, now we're going to come in a little hiccup. Anybody remember what that value was? The mean. You go back to the problem, there is no mean, but there is enough information to find the mean. Ready? Here we go. We can find the mean given the info. Within this curve, 95%, what's that from? What's that from? Okay, 95%, or we just went over this one. Is it within? Within? -2 to 2 are between 62 and 78. So they're telling us what's at -2 and 2. What value are we still missing? Which is where? In the middle, right? Right in the middle at 0. Remember our curve? Right at the middle at 0. How do I get there? How do I get there? I know I'm at -2 or I'm at 2. How do I get to 0? Okay, so let's say we're going from 62. How do I go from 62? I'm at -2 to 0. Add y8. What's the standard deviation? So if you add 4, that gets you to -1. Add it again, you're at 0. So yes, I'm adding 8. So what's your mean? 70. That I can plug in the calculator now. Everyone all right on how we got there? And now what's that next number? What's this the symbol for?
That's the population. Standard deviation.
Yes, standard deviation. Population in particular. And we already knew that was 4. Pace, I don't know what's going on with my calculator. It just puts it in a list for some reason. Yeah, I have no idea why.
Oh, there we go.
That has nothing. I did not want to do that at all.
Sorry. I'm so sorry.
just gonna go back to it, but all right. It's not multiple choice. The work you show is what's in your calculator screen right now. 74, comma 1E99, comma 70, comma 4. And I'll make the rounding directions up here. Can you guys go nearest thousandth? What's the probability to the nearest thousandth? Woo! 1, nearest thousandth, point.
I knew it was gonna be me.
I was slacking. I'm gonna write it down.
Breaking news.
All right, I got nearest thousands. You said 1.159.
No, that's good.
That's all I'm saying. It's good in my books. All right.
We all good? Why is this one tough? You knew where to go in the calculator and you're typing in, you're going nuts. Missing the meat. Okay? Good talk. Here we go. Box of cereal. Here we go. 7. Anybody want? I'm going to regret this. Go ahead, throw it out. Cereal.
Captain Crunch with berries. Captain Crunch with berries. What? Captain Crunch. Are you able to swallow them? Yes. They dry your mouth. What? Beyond Lucky Charms.
Okay, can I ask now? Anybody mix cereals?
If I had to,
Yes.
Like a healthy with a non-healthy one.
Yes.
Like if I go Honey Nut Cheerios with Fruit Loops.
Honey Nut Cheerios aren't so healthy. Well, but Honey Nut Cheerios, that's too many loops. Honey Nut Cheerios.
True.
I might go with.
A lot of color though.
I might go with. Like,
Toppings?
Lucky Charm. Some people put sugar on their cereal. I didn't know people did that. Who likes Raisin Bran? People put sugar.
That's psychotic.
Toppings?
Like just imagine
Strawberries? Anybody go bananas?
Bananas.
Okay, strawberries.
Bananas?
You ever had puffins?
Puffins are
Okay, try this. Here's a little tip.
I've asked this of my freshmen earlier in the year, and hot water. What are you doing? Or orange juice because I didn't have any milk available.
They're definitely
What kind of parents
Not
are
a
teaching
lie.
their kids to put hot water?
This is why freshmen suck.
Put frozen blueberries.
I'll just eat it.
Try that
I'm
out.
not gonna put
It's so good. Frozen blueberries in it.
That's fine. All right, fine. Fine. But orange juice or water.
Do you have some type of peanut butter cereal and you put bananas on it? Yeah. Oh, come on. Come on.
And this is where I'll end it. Animal crackers on top. You already have the milk in there.
I recognize. It's already have what? Wait.
I'll do bananas and animal crackers.
Do you put the milk in? You already have what?
Milk.
in there?
Milk.
You already have.
What's wrong?
You say milk.
Who doesn't do that?
It's milk. I don't know. It's not like a staple. I don't know.
Milk first or cereal first?
Cereal.
Okay.
How can you?
I don't know.
Then you don't know how much to put.
Yeah, exactly. How you know how much milk to put?
Some people milk first. It's weird.
No, I got to go cereal first.
Justin likes milk.
That's fine.
He says hello. What the heck? I say Jenga. It is Jenga. What? People call me Jenga.
No, no one said that.
No one
Oh,
said
yeah.
No one said
No one's ever said Jenga.
No. How do you say
I
math?
used to call it Jenga.
Oh.
Math?
Now I call it Jenga.
Math?
I'd like to do some more.
Okay. All right. All right. Let's get back here then. Good talk. Good cereal discussion.
I'll interchangeably do.
Yeah. All right. Yeah.
Okay. Here we go. Distribution.
Like I'm used to both.
All right. All right. Boxes of cereal, approximately normal. Maybe we'll have to go to CDF. We'll see in a second. The mean is 20. So if it's normally distributed, the mean's 20. That's where? That's at 0. right? That's 0 on my curve if it's normally distributed. Ooh, I'm changing this up. You can do this. I got faith in you. You can do this. I want to know what's the scores within 1.5 now. Within not 2, not -2 to 2, not 1 to -1, but now -1/2 to +1/2. Where are those values? Ready? Can anybody help me? If I'm at 20 right now, and that's my 0, my mean, where's +1 going to be?
It's gonna be at 22.
How do you know it's at 22 and not something else?
Because standard deviation is 2 ounces.
Standard deviation is 2. I add 2 to 20. Here's +1, everybody. Where's +2 going to be?
24.
20.
Dang.
All right, so where's 1.5 going to be?
I don't know, man.
Right in the middle.
Right in the middle, which is
23.
23. Now get me to -1.5 now. So what's -1? What scores at -1, or what weight at -1? 18. I keep subtracting 2. What about at -2? 16. So what's at -1/2?
17.
Okay. So what weights are within 1.5? 17 to 23. Everyone all right on how we got there? I know usually I don't ask about halves, but we could here because it was right smack in between. All right. And now we can answer this pretty easily. Which of these values is the best estimate of the boxes that are more than 1.5 above the mean? Above the mean, not below, above. So what score was at 1.5 above? 23, right? That was at 1.5 above. So what's the best estimate? Something that's above that? Choice 4, 36. Yep. Kids are good. Questions there? And I think that's where we'll end it.
Are you returning that?
And then you guys are just going to get in groups and work on Monday. Good discussions today.